Now we are at the very last part, which is, how do I know what I need when it comes to climate information? And the answer to that is, it really is up to you. And here are the 3 steps you can follow to figure that out. Step number 1 is this. What impacts do you care about? This is not a question that a climate scientist can answer. What does your system respond to? What concerns do you already have? What risks do you already face? What challenges are you already coping with? Are you concerned about algae blooms? Are you concerned about endangered species? Are you concerned about the impact of drought on your system? Are you concerned about the impact of invasive species like Asian carp? Are you concerned about fish kills? Are you concerned about water pollution? What are you most concerned about? That is question number 1. Then question number 2 is, what's the connection between what you're concerned about and one or more climate or weather events? Is what you're concerned about affected by runoff that's affected by heavy rainfall? Is it affected by wildfire or drought? Is it affected by storms? What is your risk affected by? For some purposes, you can stop right here because you might be worried about something. The primary impact on your system might be something that might be pollution overflow from a local, industrial complex or factory or town or untreated sewer system. And that could be mildly affected by climate, but the biggest impact is simply how much is flowing into the water system. So for some purposes, we can stop right here and we can say, we know enough about the sources of our problems and the vulnerability of our system to build resilience into future planning and to make the changes that are needed. Because the biggest problem we have is not how big the hurricanes are getting. The biggest problem we have are the sewage inflows, for example. For other purposes, you can say, all right, we know that we're being affected by climate, but all that really matters to us is the direction of the trend. So is it getting warmer or cooler? Is heavy rainfall increasing or decreasing? Are winters getting warmer? Are summers getting longer? Are heat waves getting more intense? Is evaporation increasing? Is soil moisture going down? We only need to know the direction of the trend in order to make our decision. Because sometimes a decision doesn't depend on how big it is, it just depends on whether it's happening or not. Our management decision might be the same, regardless of whether a heat wave is becoming twice as frequent or 4 times more frequent. So if that's the case, then we can get the information on the direction of the trend from sources like the National Climate Assessment. From Volume 1, which you can find online again at science2017.globalchange.gov. You can see we've come full circle from the first episode here. Or, very specifically for each region, from NCA2018.globalchange.gov, which is the second volume. You can see broad-scale trends, and for some management decisions, that might be all that you need. And if you do, that's totally fine. There's no reason to go any deeper than you need to. But for some applications, you do need more information. So for example, very basic example, say they're replacing a storm sewer system because they know that they're getting combined sewer overflows much more frequently, and they know that they're getting them more frequently because we're seeing more heavy rainfall events. So you're replacing these pipes, and it's very expensive to do that, and you know that you want the pipes to last for 80 years. So you need to know, is heavy rainfall going to be twice as frequent or 5 times as frequent or 10 times more frequent? Is it going to be twice as intense or 5 times more intense or 10 times more intense? Is the total amount of rain falling in heavy downpours going to be double or triple or 5 times what we have today? You need this information because you need to know what size pipe you're going to put in. If you put in 2 big pipes up front, the cost will be more than you really had to spend. But if you put in 2 small pipes up front, even if they're bigger than the ones you have today, you're going to have to dig them up in another 20 years and replace them, and that cost will be astronomical. So in cases like that, we do need quantitative information. And that's where these climate projections that I've talked about come in. So you don't need high-resolution climate projections in every single circumstance. You have to go through kind of a decision tree of what is the most important risks or challenges my system is facing? Are those risks being affected or exacerbated by the impacts of a changing climate? Is knowing simply the direction of those trends enough for the decisions that I am able or empowered to make in my system? Or do I actually have choices to make that I would make differently, depending on if I had some actual numbers or an actual range attached to the information? Though that's the decision that we have to go through. And I want to leave you with 2 resources that I think can help. The first resource might seem kind of strange. It's actually a manual on how to use climate projections for hydraulic engineers who study transportation infrastructure. And you might say, well, what does that have to do with me? It has a lot to do with you because 99% of what we wrote is applicable to any field and any system that's using climate projections. So this manual, the draft has already been published online. I'll show you what the website looks like right here. And I highly recommend, if you're interested in extreme precipitation, because that's what it focuses on, I highly recommend reading the chapter on extreme precipitation. They have another one on sea level rise if you're interested in that too, because it will take a much deeper dive into the information I've talked about here regarding global climate models, downscaling, translating that information into usable information, and actually developing impacts and making decisions based off them. Of course, I've already recommended the National Climate Assessment multiple times, both Volume 1 and Volume 2. I've recommended our Global Weirding series as well, if you want something a little bit lighter and a higher level, just to kind of give you the big picture. But I'm excited to say that we also have a book coming out in November 2020 with some of my co-authors, all of whom study downscaling quite extensively, that talks a lot more about the regional climate models and the statistical downscaling. So if you want to do a deeper dive, don't worry, you don't have to be a specialist, but it definitely is more detailed and more technical. If you want to do a deeper dive, I highly recommend this book coming out in November 2020 that talks specifically about high-resolution climate projections. But when it all comes down to it, the bottom line is this. We have been driving down the road looking in the rearview mirror for not just decades, but centuries. Today, our wheels are on the rumble strip, and we have to look ahead to plan for that curve in the road. Why? To ensure a safe future for us all, and again, by us, I mean every living thing on this planet. Of course, the future is uncertain. It's always uncertain. But the bottom line is this. We know enough to act.